Imagine just deleting your Uber app and suddenly buying a whole fleet of minivans. Sounds crazy, right? Well, for years, the golden rule in tech has literally just been move everything to the cloud. But recently, we've been seeing this massive, quiet shift happening across the tech landscape. Companies are actually pivoting away from this cloud everything model and going right back to owning heavy physical hardware. So why the sudden reversal?
Welcome to today's Explainer. We are pulling back the curtain on the hidden financial trap of scaling artificial intelligence and what that actually means for the systems you build and interact with every single day. We're going to break down exactly why this hardware reversal is happening, the mechanics behind it, and what it really means for the future of tech infrastructure.
Here's our quick roadmap for today. We'll start with the cost crisis, move right into mastering inference economics, take a look at how the system operates, walk through the transition process, explore the business ripple effect, and finally, look out for the hidden risks. Let's get right into it.
Starting off with Part 1, the cost crisis, and those totally unpredictable cloud bills. You can think of this as death by a billion cuts. Every time an AI model processes new data to generate a prediction or response, that computing action costs money. A single AI query in the public cloud might seem absolutely tiny, like fractions of a cent tiny. It feels like mere pennies. But when you scale that up to millions of daily users, those fractions violently multiply into massive, unpredictable bills that can literally torch a company's operating margins. It's kind of like leaving the AC on with all the windows open, except your house is the size of the internet.
Which brings us to Part 2, mastering inference economics. We need a new mental model for this.
If organizations want to survive this, they absolutely need a new mental model, and we call it inference economics. Basically, this is the relentless study of the financial and computing costs behind every single automated decision an AI system generates. When a trained AI is out there in the real world processing data, we call that task inference. And here's the reality. If you aren't measuring the actual cost of your AI thinking out in the wild, you're flying completely blind.
So, the structural solution to this whole mess, it's called strategic hybrid infrastructure. We are officially done with the cloud-only default. No way. Instead, companies are smartly splitting the work. They're still using the cloud for tasks where it's most efficient, but they are actually buying and operating their own physical servers, their on-premise hardware, for those heavy, constant AI inference workloads. It saves money, gives them absolute control, and keeps those insanely expensive computing chips running at maximum capacity without a single second of idle time.
Think about cloud servers like renting an apartment. It's an operating expense, or OpEx. It goes up and down, it's variable, and let's face it, it's unpredictable. On-premise servers, on the other hand, are like buying a house. It's a capital expenditure, a CapEx. Because you own the hardware, your costs suddenly become fixed, predictable, and totally locked down. By shifting those constant workloads onto owned hardware, companies just eliminate those wild, unexpected monthly fees. They avoid total vendor lock-in, and as a bonus, they keep all their sensitive data completely safe inside their own physical walls.
Let's move to Part 3, how the system operates. We're going to look at the hidden engine behind all this. So, how does a single AI query actually travel from your phone all the way to the data center in this hybrid setup? Well, it relies on what we call the baseline. First, a company buys just enough local hardware to handle their constant, everyday, minimum volume of AI queries. Then they deploy a software router. You can think of this thing as an active traffic cop. In milliseconds, it evaluates every incoming AI request. If a request is just part of that predictable high-volume baseline, boom, the router zips it directly to those safe-owned local servers.
But what happens when traffic suddenly surges out of nowhere? That's what we call the spike. For this, the system relies on a really cool concept called cloud bursting. When your AI query volume spikes way above that local baseline capacity, our software router seamlessly and automatically sends any unpredictable excess traffic straight up to the massive public cloud. It's like getting a superpower. You get the financial stability of owned hardware for your daily grind, perfectly paired with the infinite on-demand scale of the cloud for sudden emergencies.
All right, Part 4, the transition process. How are companies actually making this shift?
Honestly, it's a fairly brutal 6-step operational pivot. First things first, you've got to audit your cloud spend to isolate exactly how much money is bleeding strictly into AI inference. Second, you calculate the math. Third, you actually have to physically evaluate if your current facilities can even handle the massive power and cooling that these new chips demand. Only after all of that do you procure the hardware, migrate those predictable loads over, and set up continuous monitoring to keep an eagle eye on hardware health and your power costs. Now, this entire strategy really hinges on step 2, the inflection point. This is the holy grail. It's the exact mathematical moment where buying, powering, and cooling giant physical servers actually becomes permanently cheaper than renting from the cloud. Figuring this out requires deep total cost of ownership models that factor in everything: the purchase prices, the electricity bills, real estate, and even the maintenance staff. Hitting this specific inflection point is absolutely crucial, because it's the only thing that justifies this massive effort.
This brings us to part 5, the business ripple effect. This is all about redefining operations.
You see, making this shift triggers a massive cultural shockwave across an entire company's workflow and finances. Like we talked about, budgets completely flip from OpEx over to CapEx. But look at developer access. It goes from being strictly metered out, usually because everyone's terrified of running up the cloud bill, to being totally unmetered and stable. Developers can suddenly test and deploy new AI features without any panic. Plus, your hiring focus shifts dramatically. You can't just hire cloud software devs anymore, you actually have to actively hunt for data center engineers and hardware technicians. The final outcome of all this? Beautifully stabilized operating margins.
Let's wrap things up with part 6, the hidden risks, because, of course, there's always a catch.
Make no mistake here, this definitely isn't a magic bullet. Owning heavy iron is brutal. You're facing massive upfront capital costs that can seriously strain your cash flow. And let's not forget, AI chips decay so fast that your brand new server might literally just be an expensive paperweight in 3 years. On top of that, you're suddenly battling global supply chains just to get deliveries, paying for idle metal if your user traffic drops, taking on massive new physical security risks, and desperately hunting for local hardware engineers in a tech market that really only knows the cloud right now. So we've seen exactly why the tech world is strategically pulling specific, predictable workloads right out of the cloud and bringing them back down to earth. It's a high-stakes tug-of-war between absolute control and infinite scale, and it's completely driven by the harsh reality of inference economics. Which leaves us with one final big question for you. Is your organization actually ready to pour concrete, upgrade power grids, and manage real physical risk? Or are you just destined to keep paying that unpredictable cloud premium forever? Thanks for joining me for this explainer today, and remember to always keep questioning how the systems around you are built.